Hello and welcome to episode 15 of my Kerbal Space Program NASA series. Starting off with a launch of a Minmus probe being carried on a 2.5 meter Delta type rocket. I'm starting to fly a lot of these heavier rockets finless just to kind of reflect the changes in technology towards the late 60s and mid 70s, where flight control systems started getting better, engines started getting better, and it was generally accepted that if you have a large enough rocket, the mass will dampen out most unwanted flight oscillations. Aerodynamics are still an issue, but that's the greater computer power that was available at the time allowed for better launch profiles to be planned, and also the flight control computers themselves got better. So it was pretty easy to come up with easy is a relative thing when you're talking about space flight and orbital dynamics, but it was generally easier to keep the rocket pointed on its thrust vector, and so you wouldn't have situations where the airstream starts pulling the rocket off its flight plan. But hopefully this 4 times time acceleration looks a lot better than it has. I've started transcoding my videos before editing them in Lightworks instead of just messing with the raw fraps files, which, if I'd had my brain screwed in, I would have figured that out immediately. Instead, for the past couple months, I've just been importing straight into Lightworks, and Lightworks does not like fraps. And fraps comes in with a variable frame rate just because it's recording raw AVI from what you're doing. So now everything's locked to a nice even 30 frames a second. So I think my transitions look a lot better in the viewer. I hope it comes out after export, but that's enough about the boring technical details of video editing, and hopefully with that ironed out, I can focus more on actually just flying these missions and narrating them instead of talking about technical issues that bore even me to tears. But I built this to be a pretty capable little probe. I do put mystery goo containers and materials bays on them. I do transmit, which is kind of a waste because the science return on a transmit versus recovery is so pathetic that I can definitely tell that's a little bit to discourage people from just transmitting like they used to. Getting our insertion into a polar orbit so we can start mapping the surface of Minmus. And I was using the flight computer there. You'll notice I forgot to hit execute, so I actually had to do the burn myself. Like I said, I'm still ambivalent on flight computer. In the dev build of Remote Tech 2 that I'm running, it's actually a lot more capable than it used to be. And that can be a good thing or a bad thing. It's good because, you're less likely to mess up, but I try not to fly with it. I just keep forgetting to disable signal delay since I updated, so I do have it delayed now, finally. I just went into the CFG and disabled it right before recording this video. And Minmus is small enough, if you get your apoapps and periapps right, you can map it in a single pass. I have only done that once, and I forgot what I had it set to, and I wasn't about to go hop on the internet to find out. So it took me 2 passes, but that was the entire mapping operation, just 4 times as fast. I didn't cut anything out, so you can see it's still a pretty trivial operation there. Got some good science return off that one, though, which was awesome. And like I said, this is a combination orbiter-lander probe. I didn't have 2 separate probes stacked onto one another because Minmus's gravity is so low, it's actually more wasteful to have a 2-stage or 2-component mission, which, that makes a lot of sense. There's most of the bodies in the Kerbin system are the same way. I just tend to prefer dual component modules. Get into low orbit so we can start doing more observations. Harvesting all the science it can give us. And that funky little thing is a radio plasma wave sensor antenna. It's another tool for studying a planet's magnetosphere, or that of the solar system in general. Start doing orbital telescope observations. And finally we start pulling everything in and getting ready for a landing. Got plenty of Delta V in that secondary stage there, which at this point it was just bonus fuel. I honestly didn't think it was going to last this long, but I massively overbuilt it, so I thought, while I've got it, I'm going to use it. And I had the wrong overlay selected for remote tech, or a different overlay. I noticed I wasn't getting any lines between my omnidirectional antennas, and so that was freaking me out a little bit. I didn't find out until after I had landed this that I had the wrong overlay selected. So I picked a different landing site where I knew I would have line of sight to Kerbin and its attendant satellite network. Just because it's always better safe than sorry. Start getting oriented for a landing and ditch that transfer stage. At this point, it's just a matter of bringing it down for a landing. And min-miss landings to me are always the most tedious thing in the world, because the gravity's so low, your acceleration's so slow. It's pretty difficult, or like I said, it gets a little tedious trying to come down. Start doing all these observations from the surface. Can't do the RPWS. And I love this laser ablation imager. D-Magic Orbital Science is probably one of the coolest mods out there, just because it gives you a lot of different experiments you can run. It unbalances things a bit, because more experiments means more science without having to go further out. But after that mission, I was kind of indecisive as to what I should unlock with this newly acquired bounty of science. And I was angling for this node with the antennas, but I looked at my Kerbal alarm clock, and the nearest transfers I have are all like 200 days out. So I figured I could make do and probably make up that deficit before then. And I really want to get to building my supermassive rovers for my Duna mission, so I can test them on the moon. So I ended up going with these first tier rover wheels in the end. And started getting worried about my funding. Probably shouldn't have, but it's always better to have more money than less in this game. And contracts are entirely unbalanced. It's just a matter of making sure they function. I think balancing is going to come in during the beta phase of KSP development. But I've actually not done any contracts in a long time. I've just been burning money, and I definitely haven't been doing any development contracts. But I've made a rule: I'm only going to do contracts if they deal with an advanced propulsion system. And this is actually the first time in my entire history playing Kerbal Space Program I've used a dual mode engine. Sabres have been in B9 Aerospace, and I've been using B9 Aerospace pretty much since I started playing the game, but I've just never touched them. I've built SSTOs, but those tend to end up looking like SR-71 clones with turbojet engines and then a separate toroidal aerospike. So this was an interesting learning experience. And the mission is to get onto a suborbital trajectory, so we fire that up and get our apoaps raised. And I was about to just let this thing plunk back into the atmosphere, but I noticed that I would have to turn around and fly pretty much half the circumference of Kerbin to get back to it. So I just punched up my apoaps, my periaps a little bit. You can see that maneuver I've got set there, so I can fly back. It never comes out of the atmosphere. It doesn't turn into a true orbital flight, but I am able to skim through the atmosphere and come back to KSC from the other direction. Unfortunately, this is designed as an aircraft, not a spacecraft, so the aerodynamics on it are very slippery, and it's got a great lift-to-drag ratio. So I ended up blasting past the Kerbal Space Center at about 1,700 meters a second. Had to get turned around way out across the ocean to make an approach from the other direction. And as an illustration of just how far out I was, you can see that island right there, that is not the island runway, that is the island beyond the island airport. And you can just barely see the mountains beyond KSC poking out over the horizon. And this is also the first time I've used the landing instruments with a powered aircraft. Unfortunately, I didn't set up those ailerons at the back to work as flaps, so it was very hard to get this thing slowed down. And you can kind of look at my landing gear and see how it's tilted in a little bit. I wasn't paying close enough attention to their alignment inside the spaceplane hangar. So that gets a little, well, it gets a little hairy when we finally touch down. On the other hand, the flight instruments allowed me to make one of the best approaches I've ever made. Just unfortunately, some compromised decisions in the aircraft design on my part. And at this stage, the reaction wheels are totally dead. It had run out of power. I didn't put any generators on board. And the Rapier engine does not have an alternator. Makes you start veering off the runway because of that landing gear angle. And the brakes are only making it worse. And I have no steering. Drag the wheel, flip the plane. But hey, the pilot survived. And I made enough money off that contract. It more than covered the cost of the airplane. Good old Chuck Herman, back from his first visit to space. Decided to recover the wreck. And unfortunately, only got $3,300 for the recovery of that aircraft. Had another contract come up to test the Sabre engines, and I was curious to test this against deadly reentry. And it's the same aircraft. I actually kind of accidentally designed a pretty good aircraft that I can just swap engines on. I was worried about tail strike, so I put that secondary landing gear set there, just because it's a longer engine. But everything worked out pretty well. And the problem with deadly reentry is it rewrites the heating algorithm. And sometimes, it seems like every time they update deadly reentry in B9, there's a problem with the Sabres. But do an EVA or an IVA landing, it's always easier to stop when you remember to shut your darn engine off. And that finally allows me to unlock the heavy rover wheels. Like I said, science payouts are pretty well unbalanced. I was tempted to go into my save and edit some of that stuff out, but at the same time, it makes sense. That's some pretty advanced technology. And like I said, balance is going to be tackled later. It just bothers me that I get so much of my science from these contracts instead of actual exploration. But that really is so much of developing hardware for space is from, you know, actual design and development testing, so it makes a little bit of sense. So I'm not going to be too broken up over it. But these are my heavy rovers that I'm designing for. First, they're going to be tested on the moon to make sure lower gravity is not going to cause problems, which I'm sure it will, but we'll iron all that out when we get there. They're built on the same chassis, that girder with the ruggedized rover wheels, and these will fit into a 3.75 meter fairing. That's my biggest concern in designing these, is I want them to fit into a fairing without poking out. But one is for transferring passengers, and the other is a cargo. It's a heavy cargo hauler, which also doubles as a. They can both have limited fuel transfer capability, as you can see those KSPX cylindrical tanks there. We're doing some tow testing here to simulate one rover having the battery go flat. I don't have any solar panels on them, and that's by design. I want to make it so they have to be plugged in when they're done being used. But the uphill tow testing goes reasonably well. Unfortunately, we run into issues when we try and turn things around, which requires some creative solutions. Yes, there's a reason why we use tow bars when we're actually towing cars instead of just ropes. Thwomp. However, we are equipped to overcome this by relocating a radial connector port. Fortunately, we grabbed the wrong part, which was trying to grab the end of the tow cable. And I have tested these things with a ground pylon and a radial adapter port. You can have a Kerbal run the winch out and then pull the rover up using its own winch, like a good old boy back in the backwoods. Set the brakes on our stricken rover. And he decides to get the heck out of the way because he really doesn't want to be there if this works as planned. A little bit of maneuvering shenanigans cut out, and change the speed of the winch here using the KAS interface. And the brakes on the passenger rover are set. I do this pull operation with the winch, not with the rover. And that's, if you're going to pull something with a vehicle, make sure the winch can handle it. Don't just wail on it with the car. The slow speed keeps from dragging it completely over. With all that handled, the cargo rover pulls up completely against the rear of the passenger rover for downhill towing operations. Because when coming downhill, having any slack in that cable, the fear is that you're going to have a collision. So by keeping them in contact with one another, it ensures that, well, it really eliminates that possibility. Just about getting to the crest of the hill. It's already downhill, but it's not enough grade for me to consider a satisfactory test. The problem is, if you overwinch this, it tends to pull it pulls them together, and the rear wheels of the passenger rover will lift off the ground, and the front wheels of the cargo rover will lift off the ground. Yes, I know that from experience. And finally, what I said I was going to get around to in the last video is going to be our final launch for this video. We're putting a fuel depot into orbit around the moon. It's unmanned at the moment, but it has provisions for crew. It's not going to be perpetually manned. It's just going to be, say I have a crew transfer vehicle arrive at the moon, and I'm not in any position to transfer them immediately to the surface. We can offload the people we're moving and then send the transfer vehicle back to Kerbin without having to just hang around all the time. It is the moon's waiting room. Burn out our transfer stage. Go to our orbital insertion stage to finish the transfer. Gonna make sure we get our periaps up, which I could have kept it at 0 to make sure this fairings would smack into the surface, but my main worry is this thing has a docking port attached to the that fairing base, and those tend to be a little more wobbly than just being attached straight to the fairing base. And those fairings supply quite a bit of rigidity. We get our solar panels deployed, and it is well on its way for a Munar encounter, hopefully to insert into orbit cleanly, refuel the sky crane, and then the sky crane can bring our first stage of the HAB module down. As always, thank you for watching.